Election ballot asks voters to select 5 city commissioners from a group of 17 candidates. And how many ways can this be done? So ask yourself, permutation, does order matter? Combination, or is it just a simple slot problem? Well, we are selecting, which is a big key to tell us it is a combination. So we have 17 candidates, and we are choosing 5 of them. So my formula tells me 17 factorial over 5 factorial, 12 factorial. So to start writing this out, this is 17 times 16 times 15 times 14 times 13. Pick up with the 12 and cross out. And then 5 times 4 times 3 times 2. So what I notice here is that I could do 3 times 5 will wipe out a 15. I could do 4 times 2 is 8, which will divide into 16 twice. That's just a little quicker way to do the arithmetic. So you're looking at 17 times 2 times 14 times 13, which is 6,188. In a race in which 10 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in? Does order matter? Absolutely, because we're talking about a first place, a second place, and a third place. Order does matter. Mutation, and we are looking at 10 automobiles, and we're going to order 3 of them. So that formula is 10 factorial over the difference between these 2 factorial. That's the old formula, it's not the combination formula. So this is 10 times 9 times 8, and we quit writing there because from the 7 on down, we cancel out with that, and this is 720. Now, when I said it was a permutation, you might have said, hey, I think it's a slot problem, and you're right. We could just use blanks here and do it from this standpoint of how many cars could finish first. There are 10 cars that could finish first. Well, then how many cars are left to finish second? There are 9. How many cars are left to finish third? There are 8. And there's the same thing. So you can use the slots or you can use the formula. An ice cream store sells 5 drinks in 5 sizes and 6 flavors. And how many ways can a customer order a drink? Is this a permutation? Does order matter? No. Is it a combination? No. It is a slot problem. This is one of these where you have any of 5 drinks you could choose, and then you could put it in any of 5 size cups and 6 flavors. So multiply all that together is 150. How many different committees can be formed from 6 teachers and 43 students if the committee consists of 2 teachers, we're going to pick 2 teachers, and 4 students? Permutation? Does order matter? No, it is a combination. The combination for the teachers is there are 6 teachers, we're choosing 2. For the students, there are 43 students, we are choosing 4. So this is 6 factorial over 2 factorial, 4 factorial, which is 6 times 5. Quit writing there. The 4 will cancel out over 2 times 1. But 2 into 6 is 3. 3 times 5 is 15. This is 43 factorial, 4 factorial, 39 factorial. So this is 43 times 42 times 41 times 40 times 39, but that's going to go away. And the bottom here is 4 times 3 times 2. And then I can do some canceling right here. I know that 4 goes into 40 10 times. 3 goes into 42 14 times. And I could further cancel. 2 goes into 14 7 times. So with all that canceling, I'm looking at 43 times 7 times 41 times 10, 123,410. Multiply those together. This is what I get, 1,851,150.